Hello everyone. Today in this video tutorial I will be introducing to a new humidity and temperature sensor that's at HCPA-5V-U3. Now to gain more knowledge about this sensor, what we're gonna do is to roll upon the website that is controleverything.com, and here let's search this sensor and let's see what we got it. It says that it's a humidity and temperature sensor plus minus 2% RH plus minus 0.3 degrees Celsius I2C Mini Module. It's a very high accuracy, as you can see. Precision is very good, and there are a lot more features as you can see on my screen. You can also purchase the sensor from here. Well, I will be interfacing the HCPA-5V-U3 humidity and temperature sensor with a particle photon, and let's go to resource tab, and here comes the particle code sample. You can download the particle code sample as a zip file from here, this very link. Also, you can have the code from github.com, and the repository there is Control Everything Community. Now let's have a look over the hardware. We need to set up some connections for that. Let's have it. For the hardware setup, the first required thing is the particle photon, which you are able to see on my screen, and this here is an I2C Shield for the particle photon. Now this is available on the website controleverything.com, and the reason we are using is to make connections with other I2C devices and a lot easier. So gently place the particle photon over the I2C shield and make this connection. The next thing we require is the most important thing, that's the sensor HCPA-5V-U3. As you can see, it's a humidity and temperature sensor, and this here is a connecting cable. Now make the connection among the cable and the sensor, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and same goes for the I2C shield. The last part is to power up the particle photon, and for that we require a micro USB cable just like this, and then we are done. Now the next thing is to look over the code. Let's have a look over that also. For the interfacing purpose, what we require is to locate the particle code, and let's see what we got in the github.com. As you can notice on my screen, log in here and search for the repository that is Control Everything Community. Now here we have to search for the sensor that is at HCPA-5V-U3, and we got that particle code is here. Now let's move on to the instruction part, where we have the instruction lays, and it says that log into a particle photon and set up on the device, and the steps are this very link. Let's open up this link so that we can have a better perspective regarding the setup procedure, and you can see all the relevant information is provided on this very link. Note it down and follow the procedure. The second step is to download or git pull the code, and the online ID we have to copy the code, entire code, and build.particle is that particular link on which we have to save the code, name it as you can see, just like that. Also in the last part we have to verify and flash the code on the particle photon, as you can see, and the code output will be displayed in logs at dashboard, and this dashboard user logs will have the relevant output in humidity and temperature. As you can see, it's a temperature sensor, just like that. Now get back to the code. As you can see, it's a particle code .iun extension, as you can see, and in the code please note down that we have included some libraries. Header files are there, application.h and spark wiring I2C.h, and then we have defined the address of the sensor, that is 0x28. We have some variables initialized, as you can see, some here, and in the void setup function we have initialized I2C communication as master along with serial communication where baud rate equal to 9600, and then we have the writing part where we are sending the start command, which goes for 0x80. It's a general command, as you can see, general write command. Now in the void loop function we have a request of 4 bytes and reading of 4 bytes, and it's a general read. As you can see, the data is in the form of humidity and temperature. After that, the conversion of the data takes place, which is according to the guidelines and the formulas provided in the data sheet for HCPA-5V-U3. At the very end of our code, after so many calculations, we want to display the output on the dashboard, which is in relative humidity, percentage RH, along with the temperature in Celsius and Fahrenheit. So this is how the code looks like. Now let's see how it works. Now in the working environment, the first step is to copy this entire code of the particle, as you can see on my screen. Then open up the build terminal, as we have discussed, to the build link, and here we have to create a new file and then save it. And the step, as you can see on my screen, here we go, and here save the name HCPA_5V underscore U3, and let's save it. Now verify and compile the code. As you can see, it's great work. Now flash the code. While flashing the code, we have to check for the magenta flash, which confirms that code is good to go. So just now we have the magenta flash, as you can see on the particle photon, and the successful notification is here. Now let's open up the dashboard user logs and we can have the output on the screen. And as you can see, we have the temperature in Celsius and Fahrenheit along with the relative humidity. Now when I blow some air over the sensor, you can notice the change in relative humidity along with the temperature in Celsius and Fahrenheit. And the changes are there. As you can notice, there is an increase in relative humidity along with the temperature in Celsius and Fahrenheit. So this is how the sensor works, and along with the particle code and the particle photon. Now what do we require is to have a look over the benefit, feature and the applications regarding this particular sensor at HCPA-5V-U3 humidity and temperature sensor. HCPA-5V-U3 offers the most advanced and cost-effective humidity and temperature sensing solution for virtually any type of applications. Capacitive polymer sensor chip developed and fabricated in-house and CMOS integrated circuit with EEPROM are integrated into one embedded system in a reflow solder-able SFD package. These features make it very useful for a lot of applications such as energy saving, HVAC control, automobile and transportation, process control and instrumentations, and mass quantity application. This sensor can be purchased from this very site, that is controleverything.com, and you can have the code from the resource tab, and after that you can download the code as required. You can also have the code from github.com, and the repository there is Control Everything Community. In the end, I would just like to make it clear for any part, if there is any further query, you can reach us on controleverything.com and post your comments on the community page. For blogs and articles, you can have a look upon instructables.com. And to subscribe more video tutorials, you can have a look over our YouTube channel. I hope you enjoyed this video and have a good one yourself. Thanks a lot for watching.